So we talked about the parts of the polynomial, and you are responsible for that. You're responsible for the vocabulary that goes with polynomials, and a polynomial is just a mixture of letters and numbers, but the letters have a special name when we talk in math terms. So what are the letters of the alphabet called?
Variables?
Variables, right? Because they are going to vary. When we're using them to calculate things, they're going to, the value that I put in there, the number that I put in there is going to vary. So the other thing we talked about is if there's a number attached to a variable, like through multiplication, that's called a coefficient. You already knew what an exponent is, but we have letters and variables, coefficients. If there's just a lone number, like a lone integer, it's called a constant. And then we also learned that polynomials can be any size. There's no limit to the size of a polynomial. I mean, a polynomial could have 1,000 pieces to it. We don't see those in math class. We're usually restricted to the numbers, but a one-term polynomial is called the monomial. If there's two, it's binomial, three, trinomial. After that, we just call them a polynomial. What else? So this is how many terms. Terms are connected by pluses and minuses. 3n means 3 times n. That's just regarded as one term, right? Multiplication glues numbers and letters together. That's just one term. So I think everything was okay. What's not a polynomial? We can't have any variables in, like, underneath in the denominator in a fraction. And we can't have any square roots. It's right there. Okay, so how did assignment 1 go? I'm just going to kind of double check. This is something I wanted you to work on yesterday. Any questions on page 5? No? Okay. How about page 6? You have to fill in a chart. No? You good? Okay, page number...
I got a question on page 6.
Number 4, I want to ask you guys about number 4 as well. What's your question?
Number 3, they got that x3, and then they say it's half.
Where are we? Yes. We talked about that yesterday.
They say half in
Yeah.
the coefficient
I actually
part.
even wrote that example on the board on Tuesday when we were here, right?
Yeah, I didn't get it.
Well, x divided by 2, there's really a 1 in front, an invisible 1. So I can... x over 2 is the same as 1/2 x.
Yeah, but it says x with a 3 cubed or whatever it is.
Okay? So 1, 2, 3 terms, agreed?
Yeah,
Trinomial?
yeah.
Okay, there's a coefficient of this, there's a -8 here, right? Coefficient of -8. -8 is multiplied by the x, agreed?
Yeah.
And then this 1/2, the 1/2 is actually being multiplied by the x cubed. Okay? So the other coefficient is 1/2.
Multiplied by the
X cubed, because the x cubed is really x cubed over 1. 1 times x cubed is 1x cubed. 2 times 1 is 2. We don't write coefficients if they're 1s. We talked about that on Tuesday. In math, we don't write a coefficient of 1. So that's why the x cubed over 2 is the same as 1x cubed. The variable is x, and the constant is positive 2. All right, someone be brave and give me a trinomial with a negative leading coefficient.
Minus 3x.
Minus 3x
Plus 2.
plus 2
Plus 2ab.
plus 2ab. Okay, is that a trinomial? Did Delmar get a trinomial? He didn't?
Yeah, he did.
Yeah, I think he did. Does it have a negative coefficient?
Yeah.
Leading? Yeah. Yeah, that's fine. What about a polynomial with 4 terms and a constant of 5? Bottom shelf, Robbie. Yeah, that one. 4 terms with a constant of 5. There's millions of answers. Trillions.
5.
So the same answer above and add plus 5.
Same answer with what?
Another like an additional plus 5.
That wouldn't work. Because then I'd have to combine the 2 and the 5,
Oh, right.
right? It could be this, it could be negative 3x plus 2y
Yeah.
plus 2ab plus 5, right? That would work, right, Devin?
Yeah.
Monomial with 3 variables. Someone other than Delmar. No offense, Delmar, but you've already answered a couple of times. No, that's good. I'm going to challenge someone else. Give me a monomial with 3 variables. What are the first 3 letters of the alphabet? Come on, you guys. Thank you. A, B, C. Okay, there's a monomial. I'll give a coefficient to 6. A binomial with a fractional coefficient. Inesa, give me a binomial with a fractional coefficient. A third x minus. How about minus y? There. Done, right? Okay. Combining polynomials. I did quickly kind of introduce that to you guys. I did post notes on the blog. Remember I said I was going to post the answers to all the examples, which I did. So it's on the blog. Combining a polynomial means the exact same thing as combining integers. You're just combining numbers together using, the rules of plusing and minusing. But in polynomials, I can only combine like terms. What does that mean? What does a like term mean?
Same variable?
Exactly the same variable or variables with the exact same exponent, right? So for example, 2x plus 3x squared, they have the same variable, but the exponents aren't the same. Agreed? So they're not like terms. They share an x, but not like terms. So if I told you to simplify, you would have to say to me, it's already simplified. I can't do anything more to it. That's it. Can't go any further. However, if I had 3x squared plus 2x squared, same variables, same exponents, they're regarded as like terms, that simplifies to 5x squared. Once I've identified the like terms, I kind of ignore them for a moment, and I just say, okay, well, what's positive 3, positive 2? It's positive 5. Okay. So that was the next lesson, combining like terms. As I said, I did post all the examples. So the first couple of examples were just recognizing like terms. I did leave the combining with brackets till today. There aren't any in the exercise anyway. And then I assigned page 10 as well, and I asked you just to work through that. Now I know a lot of you weren't here yesterday, and I did tell you I wasn't going to be here, so that's fine. Were there any questions at all about page 10? Yeah. C? Okay, let's take a look. Hopefully there's not a wrong answer, Jordan. All right, so I'm quickly scanning. I see some like terms, right? I see terms with A's and terms with B's. So let's take a look at the A's first. I have 7A minus 4A. So what would that give me? Maybe I'll even do this. I'll write them, kind of clumping them together. I have a 7A minus 4A, and I also have a minus 3A. Agreed? Down here. So if I just kind of grouping all my terms with A's in them, that might be a strategy you want to use when you have a larger polynomial like this. Yeah. So I have that, that, and that. And then these two are like terms as well, right? 2B plus B. Okay, so Cliff, I heard you say 0. So I have 7, take away 4, take away 3. That would be 0, right? Then I'd have 2B plus, what's the coefficient here on the B? It just says 2B plus B. It's a 1, right? So if it's not written, it's regarded as a 1. So 2 plus 1, 3B. And that would be my answer. The only one with brackets in it was this one. And there's, when there's just a plus sign in front of brackets, nothing really happens, right? Brackets do mean multiply, but this would just be 1, right? So it would just end up being 2a plus 3b minus a minus b. So if you just have a bracket, or sorry, a plus sign in front of a set of brackets, basically nothing happens. You could just rewrite the polynomial without the brackets. If it was a negative sign, though, you'll see that something quite different happens. All right, so what would be the simplified form of this? I've got 2a subtract a. Just a, right? It would be 1a, but I don't write the 1. And then I have 3b subtract b plus 2b. And that's it. Okay. Did you guys find this quite simple? Let's move back a page. Let's just talk about the brackets, because I think it's worthwhile talking about brackets, because even though there's not a lot of, there are no questions with it in your assignment, I'll have to give you another assignment maybe with some brackets. I know that brackets cause problems when we were just working with integers. So basically what this summarizes to, if it's just a positive sign in front of a set of brackets, the brackets can just be removed without changing anything, because a positive 1 doesn't change anything. However, if there's a negative sign, the sign gets multiplied through, like the negative 1 gets multiplied through. And what happens is when a negative sign is in front of a set of brackets, the sign of each term in the brackets flips to its opposite. That's the net result, right? Because once again, 5x plus 3y, there's nothing in front of the 5x, so it's just, I guess, a positive 1. So the brackets just get removed, and the 5x plus 3y remains. A negative sign in front of a set of brackets, though, converts every term inside to its opposite. The 2x was positive, so now it becomes negative. The 5y was negative, now it becomes positive. And the reason that happens is there really is a negative 1 here, right? So negative 1 times 2x is a negative 2x. A negative times a negative is a positive. Okay. Then when we combine our like terms, 5 minus 2 is 3x. 3 plus 5 is 8y. And we'll just do this one, even though, like I say, there's nothing in your assignment that's technical. If brackets are nested, that means you've got more than one set. You just work inside out. So if I look here, I've got two smaller sets of brackets inside these square brackets. So what happens is I'm going to remove these middle brackets first, the little ones. A minus sign. This becomes negative 2x. A negative times negative is a positive 4y. A positive 3 stays positive 3, and a positive times negative stays negative. Okay. So now inside these brackets, you've got a choice. You could actually have combined all these first, but for this example, we ended up multiplying the negative sign through all the terms. So I get a negative 1, positive 2, negative 4, negative 3, positive 5, positive 7. In the end, I've got like terms with x's and then like integers. Combining them all, we get a 10x. Because 4 plus 2 is 8, minus 3 is 5. Something doesn't look right here. Let's try this again. 4 plus 2 is 6. Yeah, 6 minus 3 is 3, plus 7 is 10. And then the negative 5, positive 5 disappears. All right. Okay, let's try this last one together. I've got small in front of large, so those are the ones I'm going to remove first. Everything else has to get rewritten, which is kind of a pain, right? But so inside the square brackets, I have 9. This will be a negative 2y, and it'll become a positive 3. And then nothing happens here, they just remain positive 3x squared minus 5, and I close my bracket. Okay? So I'm going to get a 6x squared plus 4y. Again, you could choose to, I think I'm going to do this, I'm going to simplify the brackets first. So inside the brackets I have 9 plus 3 is 12, minus 5 is 7, and then I have a minus 2y and a positive 3x squared. I find that just makes it a little simpler. Okay, what does a plus sign in front of a set of brackets do to everything inside the brackets?
Takes the brackets.
Yeah, it does nothing, so I just take the brackets away. So I have 6x squared, positive 4y, plus 7, minus 2y, plus 3x squared. My very last step, I have like terms of the 6 and the 3. They combine to be 9, 9x squared. And then I have 4 minus 2, so I'm left with a 2y. And then my constant is 7, plus 7. And that would be it. Can't do anything more, because now I'm left with unlike terms. So I think students just have to get over the fact that sometimes your answer doesn't look much better than what you started with, right? Because you're not going to get that nice, neat little one number answer. It can be an expression still that would be your answer. All right, if you didn't finish assignment 2, I'm going to give a little bit of time. I'm going to get you to finish assignment 2. There's number 11 to do. A couple of these are a little more thinking, and then I just want to talk to a couple people, and then I am going to start, unless there's questions, we will start talking about multiplying polynomials. Okay, we'll have to do a bit of a refresher on that. So